everybody. Welcome, and thanks so much for joining us for Creaform's Ask an Expert webinar. Um, this is the second one on our series, and today we're presenting Get It Right the First Time Product Design. I'm Mia Magruder, and my colleagues Matthew and Payam will have a great presentation to share. They'll show us how to scan and reverse engineer and design parts to fit existing ones in mere minutes. But first, let's do a quick poll while we're waiting for more folks to arrive. So have you ever used a 3D scanner for product design? We've got a couple of options there. And just a quick reminder before we get started, we're taking questions today. Type your questions throughout the presentation into chat. We want to know, what are your challenges? How can we help? What kind of work you're doing and where you think a 3D scanner might fit in. And if you have any technical difficulties today, don't worry, don't stress about it. Sometimes the settings in GoToWebinar can mess with people's audio video, but we'll distribute a full recording of the presentation later this week. And for any upcoming webinars or additional training, please visit us at creaform3d.com. We also have a very active YouTube channel with additional training. So again, for those just joining us, we are running a poll right now. Have you ever used a 3D scanner for product design? I'm going to close it in just a few seconds. We're very excited to share the next episode in our Ask an Expert webinar series today. All right, I'm going to go ahead and close that poll and share the results with you. So it looks like we have a good percentage of people who have used the 3D scanner for product design before, and we're excited to share with you a little bit more on our GoScan Spark and the software solution Creaform has. So with that, I'll ask Matthew and Payam to introduce themselves and dive right in.
Good afternoon,
Matthew?
everyone. Yes, good afternoon, everyone. My name is Mathieu Magnan, and I'm regional manager here with Creaform. I have joined Creaform in 2005 as an application engineer, and I've moved on to project management and then sales throughout the time. So I've been within the company for the past 15 years.
Hello, everyone. My name is Payam Hariri, and my background is mechanical and aerospace engineering, and I've been with Creaform for the last 5 years, helping many companies implement our solutions for their product design workflow. And today we're gonna start with a presentation on a sample reverse engineering project that we've picked and created for you guys, and we're gonna go over that. And first, I'd like to start with a presentation and to give you an overview about who Creaform is first. Then we'll go into the introducing our solution, and we'll look at an example. So let's get started on that. So Creaform, our headquarters is based in Canada. We are a manufacturer of metrology and 3D scanning equipment. We have 16 offices around the world in 13 countries, so covering throughout the globe. I'm personally based in our Irvine office in California in the United States. Creaform has been innovating for 17 years, and we've had over 30 product launches, many different metrology equipment for various use cases, and we were also acquired by Emitech in 2013. And in terms of client footprint, we have clients all over the world, and we can support operations anywhere. And to point out the main industries that we help and we serve are mainly aerospace, automotive, and manufacturing industries who constantly have a need for reverse engineering and bringing new products and speeding up product development in their workflows. And to make sure that you're aware of all the different offerings that Creaform has, we manufacture hardware such as portable 3D scanners. We also offer reverse engineering and inspection software. We also have automated 3D scanning technologies shown in the middle row on the right. And lastly, for applications that require higher accuracy on a larger scale, we can combine our photogrammetry system called the MaxShot with any of our scanning technologies or our probing technology, which is handheld and portable as well. So the product that we're gonna present to you today that is our most suitable solution for reverse engineering applications is the GoScan 3D. GoScan is a white light-based 3D scanning technology. It's very accurate, fast, and very easy to use. To take a look at the specs of the GoScan very quickly and briefly, in terms of accuracy, you get an accuracy of 2 thou or 50 microns if you work in meters. And you get a resolution of about 100 microns and a speed of 1.5 million points per second, which is quite fast, and it's the fastest 3D scanning technology that we currently offer. And the part size, the recommended part sizes to use with this system would be up to 13 feet long, although you could do longer than that as well, but the suitable one would be up to 13 feet. You might be wondering why GoScan 3D? To put it in short, because it's the fastest and easiest 3D scanning experience. And I'd like to go more in detail on that and explain to you why we say that. To start, I'd like to talk about accuracy. So with the GoScan, you get an accuracy of plus minus 2 thou and a resolution of down to all the way to 100 microns. As you can see, the GoScan, because it's a white light based technology, it can track itself using the geometry that it sees, and you can also use targets. So targets are an optional, and it really depends case by case. If the part doesn't have a lot of distinct geometries, you could use a few targets to help with the tracking. If the part does have distinct geometries, then there's no need for targets. Now let's talk about ease of use, portability, and peace of mind. So the GoScan, as mentioned, it's a standalone device. There's no external positioning system needed. It can track itself using the geometry of the part that it sees. It comes in a briefcase size Pelican case, which is very easy to carry and transport anywhere. And also lastly, the dynamic referencing capability, which requires you to not have a rigid setup, is also a huge advantage of the GoScan technology. And it ensures that you have peace of mind that if your part moved while you were scanning, your accuracy and the results of your scan data aren't compromised. Next, I'd like to talk about the preparation and how easy it is to use. It's a simple plug and play, plug into the outlet and to the computer. You have real-time visualization as you're scanning. You see the scan data, and we have actually real-time meshing, so you do see the exact mesh that you are going to end up with as you're scanning, which is a huge factor. In many other cases, there's usually some loss of data between the scan data and the meshing process. So another huge advantage of our technologies is real-time meshing. So you end up exactly with the scan data that you're seeing in your real-time visualization. And lastly, the GoScan also has the capability to scan in color and capture the texture of the part that it sees as well, which we've seen that comes in handy in marketing-related use cases. And lastly, we'd like to talk about the amazing speed of the GoScan. As you can see, it's quite fast. The real-time meshing allows you to have a file that's ready to use immediately, and you can scan large objects in only a matter of minutes. To recap on a complete portfolio of solutions that Creaform offers, we have 3 different 3D scanning technologies, as well as a handheld portable probing technology. And any of these technologies, any of these hardware solutions can be combined with either our own reverse engineering and inspection software or any third-party reverse engineering and inspection software in order to provide you with a complete turnkey solution. And the application example case study that we've picked for you is today is related to the combination of GoScan plus VX Model. VX Model is our reverse engineering software, and so combining the two, you have a full reverse engineering solution. And it's noteworthy to mention that you can also combine our inspection software with this solution, and that way you'll be able to have maximize the return on this investment and be able to have both reverse engineering and inspection solutions using the same hardware technology. And over here is just a few examples of some of our clients showcasing how they use the GoScan on various parts. And as I mentioned, this is a very suitable scanning system for different areas of vehicles, whether it's external, internal, or just a simple part. It can do different types of parts. And before I switch to my colleague Matthew to show you the video that we've prepared to showcase an example reverse engineering project, I'd like to give you a brief overview of what this project contains and what you're about to see. So in this case, we've decided to show you how you can reverse engineer an exhaust pipe. And so we're going to show you the scanning part. There's really two main steps that you need to go through is scanning and reverse engineering part of it. So VX Scan is the module that takes care of the scanning portion. And then once the scanning is done, you're going to be able to see how we can take that data into our VX model software and show you how you can extract entities very quickly and then transfer everything to your CAD software. In this case, we're going to show SolidWorks, but it's compatible with any CAD software. So you can take that data into any CAD environment and start rebuilding your parts.
Great. We're going to switch over to the video now. Bear with us while we switch screens. And don't forget to share your questions in the tab on the side as we go. We'll get to them at the end during the live Q&A. Thanks.
Today we'll be scanning the back portion of the exhaust system on this car. Although the GoScan Spark can locate itself using only the geometry of the part, it's always a good habit to put a couple of targets where there is not a lot of geometry. As you're seeing on the screen here, on the two separate frames that we have, we moved up about an inch, but on the geometry side of things, there's not a lot of differences. So in this case, it's important to use the targets for the scanner to know where it's at. When you're ready to scan, you may want to calibrate. We recommend that you calibrate your scanner at least once a week, or if you got different environment change like temperature and things like that, you will want to recalibrate. The way it works, it's just 14 position where the scanner will take some reading and the system will guide you through those different position for you to make the calibration. There it's done. Let's start scanning. So when you're using the GoScan Spark, there is three types of positioning methods available for the tracking. In this case, we're using the targets and the geometry. So what this means is the targets that we've put on the part will be used to reference the scanner as well as the actual geometry of the scan. You're scanning about a square foot, so there is a lot of different geometry that can be used in order to match different frames from the scanner together. The texture can also be used as part of the positioning method. So in this case, what that would do is it'll also use the color that you got on your scan to locate the scanner. So it's a little bit like the panorama function on a digital camera. It'll stitch all the images together using the colors that it can acquire as well. In this case, we're not using this method, we're only using the geometry and the targets. The GoScan is our fastest handheld scanner. It'll acquire 1.5 million measurements per second using 99 white light scanning lines. The scanner will give you live feedback on the distance that you're scanning. You see here the green, red, and blue lights that you're getting is the instant feedback of the distance of your scanner to the actual part you're scanning. The ideal standoff is 16-inch, but you will be able to scan from 10-inch to 28-inch from the surface. Now you may wonder, what's the accuracy of the model we're getting with the scanner? Let's take a look at the spec sheet. The maximum accuracy of the scanner is up to 50 micron. What this means is a single frame, the ones represented by the green area that we're seeing populating on the surface, has data that's accurate to 50 micron. And then there obviously is a stacking error as we're moving the scanner and populating the surface. And that's represented with that 50 micron plus 150 microns per meters. So in this case, we've got a part that's about 1.5 meters in length. So we can expect an accuracy around 0.3 millimeter on the overall length. So what we're getting is we're going to get higher accuracy on a local part. But if we were to take like an end to end on that 1.5 meter measurements, we could get an error of 0.3 millimeter or 12 tau. As you may have noticed, it only took 2 minutes 30 seconds to scan. Okay, so now that we're done with the scanning, what we will want to do is align the data. In order to align the data, the first thing we're going to be doing is bring that into VX model. In VX model, we'll create a couple of entities in order to create that alignment. In this particular case, what we're going to be using in order to do the alignment is 2 cylinders and a symmetry plane. The first thing that we're going to be doing is that cylinder that goes from one side to the other on the 2 end pipes. That will be my x-axis. If this data had to match one of our previous design, the alignment could be done on a CAD that exists. In this case, we just chose an arbitrary coordinate system to match the scan to. Every time I'm done scanning, the first thing I will do in VX model is align the data. This will allow me to have like at least regular views when I'm looking at the ISO view. Now that I'm done creating the 2 cylinders that will be used for my alignment, I will create a mesh symmetry plane. Since this part is not symmetric on the whole part, I will want to select the areas of interest that are symmetric. This will be the data that will be used to create that symmetry plane. In order to create that symmetry plane, I toggle to mesh symmetry plane and then I will draw a line just for a previous fit or initial fit of the symmetry plane. Then the computer will compute the symmetry plane itself. When you create a symmetry plane, you may want to validate if the fit is good. Especially in this case, most of the part is not symmetric and we only did a small selection in order to create that fitted plane. So what we're going to be doing here is we create a mirror part of the scan and then we will run a color map. From the deviations that shows from the color map, I can evaluate my symmetry plane and make sure is that the correct or the best fit for that symmetry plane in this case. In this case, when we're looking at the areas of interest or the areas that we think that are symmetric, there's a lot of green. And if you consider that to be green, the deviation has to be within 0.5 millimeter, we can say that this symmetry plane is good in this case. Now that we've got all the entities, we will want to create that alignment. We will want to constrain the data using the entities we just created. The first one we're going to be using will be the axis that comes from the 2 end pipes. That will be my y-axis. Then I will use that symmetry planes for the XZ axis or the center line, and then my second cylinder will be the x-axis. If I want to have the XYZ pointing the other side, there is always a way to toggle the direction directly in there. So now I'm happy with the alignment. We can say OK and close that. We're getting to the reverse engineering part of the project. What you will want to make sure is that you're running your Vegas model license on the same computer that you have a SolidWorks license. We'll start modeling the exhaust line. You can think of the exhaust line as being a bunch of cylinders that will intersect themselves and then have radiuses at the end. So in Vegas model, we'll create all of the cylinders. After we have finished creating all the cylinders that will create that exhaust line, what we will want to do now is automatically transfer them to SolidWorks. One of the nice things of using VX Model with SolidWorks is that most of the works will be done directly in SolidWorks, and that is the software you're used to. We use the cylinder center line to create a single path for which we'll be sweeping the exhaust line. I found it more efficient to extract only some of the features and bring that into SolidWorks and then come back and get the missing data in order to continue the modeling. So the first thing we did is extract the cylinders to do the exhaust line. Now we will create two cross sections to bring that to SolidWorks to create the exhaust. Once you have your cross section in SolidWorks, you can draw directly on them using the regular sketch. In this case, we represented the exhaust with a simple extrusion, and then we cut both ends with a symmetric sketch. Once we finished with the modeling, we did a couple of radiuses and also represented the flange in the center of the exhaust. I brought the resulting model back to the VX elements, and we can definitively say we got it right the first time.
All right, thanks. Bear with us again while we switch back to, we're going to switch over to Matthew's screen. He's going to share a few more tips and tricks.
Okay. Can you see my screen now, Mia?
Yep, looks good.
Yes. Okay, perfect. So what we did previously was to bring everything to SolidWorks and do an as design build of the exhaust system. What I'm going to show you here is sometimes you may want to have like a full surface of that. And one of the great options we have in VX Model is we're able to create an automatic surface and generate a NIGIS file directly in VX Model. There is a couple of tools to help you select your parts. What we want to be able to do here is to select only the exhaust and discriminate the rest of the scan. So if you use the connect tools, you can click on part of the scan and it automatically selects everything that's within that scan and that's not attached to the rest. Then you can invert the selection and it automatically chooses only the part of interest. Once you've got your part, you just have to launch the auto surface and it'll ask you what's the number of patches you're looking for. And that, depending on the number of patch and the number of control point, you'll be more accurate to your scan. Or if you put that number down, at least you'll have a lighter surface to work with. We'll just run this here. You just run the preview button and it automatically creates the surface from your scan. It just takes a couple of seconds to generate those surfaces from the scan, and it's an NURB surface that you're going to get. That can after be exported either as an IGES file or as a step and brought to your CAD software. And the advantage of that is you actually get all of the details that are on the scan and not only the ones you've modeled in your CAD software. So a lot of times if you're starting a design from the actual part, but you're not actually wanting to manufacture that part, it may be advantages to use an automatically generated surface. So you just create this, and I'll just hide the scan. And what we have here is a NURB surface of your exhaust. I also brought this to SolidWorks here. So I've got my surface that is a NURB surface, and then it's really a body in SolidWorks, and that can be used for doing Boolean operations or any type of CAD operations directly in the software, which you can't necessarily do with the STL. The other thing I wanted to share with you is since 2018, SolidWorks also added some tools. Just give me a minute. So SolidWorks added tools. Where's the? Sorry for that. SolidWorks added tools to work directly with the STL. Oh, that's sorry. So SolidWorks added tool to work directly with the STL. What you will want to do is add the mesh modeling tool in here, and then you've got some specific tools to work with the STL. One thing I have found, it's not directly in this menu, but if you use the insert slicing, you can use one of your planes and that will cut in your STL, and then the data that you're getting will be used for you to create your sketch directly in SolidWorks. So if I hide this, so now I've got this part here, which is a slice in my directly in my STL. So from there, I can create, I go back to my sketch and I can add a sketch in my plane. And then the nice thing about those tools is you can click directly on your STL and it'll build on the file. So we're really accurate to the scan when we're picking the data directly on there. Perfect. So these were the two tips I had for using the VX model or the scanning in SolidWorks. We'll go back to Mia.
Yeah, so I think we are ready for the Q&A portion. So I think Payam, you had one last slide to share, so I'll switch it to you. And we've gotten some really great questions from everybody. And I think the first one I wanted to ask you guys, so someone has asked, how does the scanner, the GoScan Spark, perform on reflective surfaces or very dark surfaces? Payam, you want to take it? Oh,
Yes. So
there we go.
in terms of reflectivity overall, I would say the GoScan does really well on reflective surfaces, but there's definitely limitations to it. So it depends on the level of reflectivity of the part that you're scanning. To give you a reference on what level it can handle really well, I would say we've tested it on many car projects, on new cars with fresh paint on them, and that's never been an issue. It does really well on fresh car paint. So that's usually the reference that I use to let our customers know on what level of reflectivity it can do and how well it does on reflective, which compared to other solutions on the market, it's significantly more capable. And in case parts do get more reflective, if you're dealing with shiny parts, machine parts, sheet metal parts that are very reflective, we have another solution, which is a laser-based 3D scanner called a HandyScan. And with that scanner, you can do up to chrome finishes without the need for any kind of powder or spray.
So another question we had is, how fast does it take to learn how to use the scanner, how to use VX model? Matthew?
So one of the things the scanner can be learned really rapidly. What we provide with the scanner is 1 day of training for the equipment itself, and then you can be proficient with the scanner in about a couple of days just practicing with the equipment. We also provide half a day of web training for the base model software. So in a day and a half of training, and within a week of using the equipment combined to your CAD system, you can be really proficient with the scanner and the software.
So I had another person ask, kind of what are some of the requirements for when you're scanning? Like, is there a required speed for your hand movements during the scanning process? How quick and easy actually is the process?
I
So
can take.
yeah, go ahead.
Yeah, it's what you need is pretty simple and easy. In terms of hand movement, the scanner is capturing 1.5 million points per second. So the hand movement, there's really no limitations to that. And what you really need is, all you need is the scanner, a laptop, and a power source. And if you're on the field and you don't have access to power, you can use our portable battery that we combine with the scanner, and that way you're almost completely portable, and you can be on the field scanning without much requirements. So yeah, overall, what you really need is scanner, laptop, and you can get going, and a battery pack.
And we have another person asking about the capabilities of scanning different materials again. So this was more specifically fabric or plastic films. Would this be the right scanner for scanning something that's protecting a surface?
It doesn't really matter the type of surface you're scanning. If you're scanning fabric, usually it's a dull surface and it's really easy to scan. The only thing I'm wondering is if they're talking about if the film would have to have a color. We wouldn't scan like a transparent film, but if it was an opaque film, there wouldn't be any problems of scanning those films with the GoScan Spark. If they have a transparent film, it can also be dusted with some powder that's meant to be for the scanning preparation.
And someone asking about sunlight. So any tips for if you're working in a sunnier environment? Would that be
So
similar with powder or a different scanner?
So
no, it wouldn't need any powder if you're scanning in the sunlight. Really, the problem would be the direct sunlight is not recommended with a GoScan. If you have to scan in direct sunlight, the handy scan would be a better option. But if you're able to get some shade, you can still scan outdoors. It's just that you don't necessarily want to be in direct sunlight with a GoScan.
And so we have someone else asking, is this the right scanner for, why is this the right scanner for reverse engineering or product development and product design?
So for reverse engineering and product design, we've taken a detailed look at what are the needs of in those types of applications, and we've understood that really the main things are speed. You want to be able to, as a product developer, designer, you want to be able to, if you're using a scanner, you want to be able to scan things fast. You want it to be accurate. You want it to be easy to use so that many people in the office without a whole lot of certifications or any specific requirements can pick it up and do a scan so that you're not limited. And so those are the main checklists that we understood that many people in this environment have. And the reason we say that the GoScan is a very suitable and the best 3D scanning experience is because it checks off all those points that are important to our customers. So it really gives you full versatility, and it's very easy to use, it's accurate, and it's fast. So, and that's really everything that I think a product developer or a product designer would want implement it in their work.
And we have someone again asking about some training about how fast does it take to learn and what experience does a user have to use this? Would a student be able to pick it up with the training and no background in engineering?
I can take this one. Yes, there wouldn't be any problems for a student to use the scanner. The scanner is really easy to use, and even the students, they usually get used to the scanner easier uh, because they're used to video games and all that. And using on the computer, it's really easy to use the scanner. You just have to start the scanner and start scanning, and usually it'll populate the surface. The only thing that it's really to get the tips and tricks and the good habits of using the scanner, but anyone can start scanning and use the experience. That's one of the purpose when we created the Go Scan. It was to have the easiest and streamlined experience of scanning.
And we have a few more questions on portability and ease of use. So how portable is it? What are the kind of battery requirements? How close or far do you need to be from objects?
Sure. In terms of portability, as mentioned, the entire system comes in a Pelican case that's the size of a briefcase. As a former application engineer who had to travel with the systems and train customers, I always carried it. You can take it as a carry-on. It's pretty small and compact, so it's very easy to use, easy to transport. And in addition to that, you would just need a laptop, so maybe a backpack that holds a laptop, and your battery pack can go in there too. You just need a standard battery pack, and that way you can, once you have all of those, you can travel with it anywhere and get started with scanning. And in terms of standoff distance from the part, you have to be between 12 to 16 inches away from the surface that you're scanning. And the great thing about the Go Scan is that you constantly have a feedback. We have two different feedbacks regarding your standoff distance. One is shown directly on the grid of the stripes, the white light stripes, which is a 12 by 12 inch grid. So you constantly have a color feedback, which tells you whether you're within that distance or not. And in addition to that, you also have the same color feedback on the actual hardware. There's LED lights that illuminate, and depending on where you are within that standoff distance, they're constantly guiding you to move closer or further and to make sure you're within the right standoff distance.
Yeah, and we have some questions of a scale. So if someone's dealing with a large object, what should they do? How can the scanner handle that? The level of accuracy, that kind of thing.
So when you're scanning a large object, there is some stacking that we're seeing. That's 150 microns per meters plus the 50. But if you really want to have an accurate model, there's always any Creaform technologies can be combined with the max shot. So what the max shot will do is you will take pictures of only the targets before you're starting the scan, and then you can run the scanner and keep really tight accuracy.
And we have a few more questions. I think this will be our last two. One is, again, kind of asking about the advantages of the GoScan Spark versus the HandyScan. So if one of you wants to speak on that.
So we chose the Go Scan because of the speed and for a lot of product design application, you don't necessarily need all the accuracy that the Handy Scan will bring you. And if you're scanning large panels and areas inside the car, you don't necessarily need as much targets using the Go Scan. That's another advantage. If you're scanning really mechanical parts, part of the engine, parts with really reflective, in this case, we would recommend the laser scanners like the Handy Scan. But if you're scanning the panels and you've got a lower accuracy need, then really what the HandyScan can provide and the GoScan would fit. In this case, this is how we would recommend to use the GoScan.
And finally, what can people expect in terms of price range? And is anyone who's interested in this solution, are there any offers or promotions that would be useful to them right now they can take advantage of for the GoScan
Yes.
Spark? Thanks, Payam.
Yes. So the investment cost for the GoScan Spark is $39,000. It's just for the scanning system. You would need to make sure that you have a powerful laptop to run that scanner as well. And in addition to that, you would need VX Model software, which is $7,000 per license. So those are the three main items that you would need, excluding training. And right now, actually, we do have a promotion on the GoScan. You would be getting a license of VX Model as a bundle with the GoScan at no cost. So you would be able to take advantage of a GoScan with a VX Model at only the $39,000 investment cost.
That's great. And I think that's all our time for questions today. Thanks everybody for attending. If you would like access to any more training, you can visit our website, creaform3d.com. We have some of our past webinars. You can visit our YouTube channel, and we have more Ask an Expert webinars coming up in our series. Thanks so much, Matthew and Payam. And if we didn't answer your questions today, don't worry, we will follow up and share the full presentation with you soon. Thanks so much. Have a great rest of the day.
Thank you.
Thank you.